Here in our factory, this is basically where things come in the back door, where we receive all of our products. So when product comes in, we actually break it down. We do audits to make sure the right product has arrived. Once that's done, it's actually staged in this area right over here where you can start receiving the product. Performance is key. We know that if we design high quality products and they perform well, that people are going to buy our stuff and they're going to want it. Quality is the number 2 thing. You know, these things are all super important to us. The third thing is product consistency. So we know if we design good products, we know we maintain the highest quality standards, and we know that we make consistently good products over the lifetime of our products. We know we're doing the right thing. We're not really big on tip weighting our products. So when we assemble our set of irons, our swing weight tolerances are extremely tight, and any set that goes out, the total range from lightest to heaviest club is set as 0.5. By sorting components, like I showed you back there at the last station, it allows us to really limit the amount of tip weight that we use in our products. We have maximum allowable weights that we allow in. All of our weights are actually custom designed, so we regulate the length of them, the diameter of them, the internal geometry of them to make sure that it doesn't affect product performance or any of that sort of stuff, to make sure the product that we're shipping out performs as designed. This is kind of our component spec station. Not quite 21st century. We obviously house all this stuff electronically as well. Thousands of documents that are in here that range back years and years and years. We have this big book that you can see here that has thousands of pages of documents. So we have a component specification for every single piece of everything that we get, from every head, shaft, grip, ferrule, screw, washer, you name it, head cover, every label that goes on all of our clubs. We have a document for all of that stuff. And as those products come in, we actually check them against these documents to make sure we're getting the right stuff. Whatever our driver loft is supposed to be, we want to make sure the drivers that are coming in are actually that loft. Our goal here is to get better tomorrow than we were today. And we do that by data collection, data monitoring, things like that, making sure that we are highly educated on what what processes we're capable in, where we need to work better, and where we need to focus our attention. Everybody in the golf industry has some sort of gauge to measure loft, lie, all those types of things, right? You have to take mechanical properties on the golf clubs. What we have found over the course of time, so we talked about how our goal is to improve every day. We need to get better. That means that sometimes we have to learn how to do things different. We have to get different equipment to actually make sure that we can measure to the accuracy levels that we want. This machine right here is our new machine. And basically this is a digital CMM and a laser scanner. So this machine on a metal wood is able to take 7 different measurements for us in about 20 seconds worth of time, accurate to within thousandths of an inch. So we know that when our golf clubs are coming in, we're measuring loft, lie, face angle, all those things on our clubs. When it gets out in the market, we know that it was good. So Alex is going to demonstrate really quickly what we do. And this amount of time that you can see him running this measurement, there's actually 7 different measurements that are going to be taken off the golf club this quickly, and you can see on the screen over here. So it's doing a full scan of the golf club face. It measures quickly and accurately loft, lie, bulge, roll, face angle, hosel length, and then gives us the data so we know whether we're on target or whether we're just in spec, and then we can take that information and feed it back and make sure that we're getting better. Favorite spots on the tour for me, because I spend a lot of time down here. We focus a lot on cosmetic durability, things like that, sustainability of our products. The thing with these processes that are back here, they're destructive tests. So I talked about earlier, we don't buy stuff we don't need. We're actually pulling product out of shipments that we purchased, that we paid full price for, that are perfectly good products. We stick them through all of these tests and we ruin them to make sure that that quality is maintained through the life of our product. And when we're done, we destroy the product and we throw it in the trash. So we do that on our dime. We actually spend a lot of money every year actually throwing good parts away because we want to make sure that the stuff is good. Yeah. We want to make sure, the running joke that we have is that we make jewelry people play golf with. We like our stuff to be shiny and pretty and perform really well, and we want to make sure when it leaves our building, it looks like we expect it to, and we want to make sure that when it gets in the hands of our consumer that it stays looking like we expect it to. These tests ensure that's the case. So all of our heads go through a corrosion test as part of qualification and part of the audits as they come in. So what this does is it basically sprays salt water over the tops of all of our heads. It gets hot, dries it. This is a 24-hour long test. The object of this test is to try to make our product rust. Our requirement is that our products do not rust. So all of our products, with the exception of raw wedges and things like that that are meant to rust, go through this test. And after 24 hours, they have to come out rust-free. We have CT testing here, which basically tests the rebound any given head. We have a ball drop test where we actually take these stainless steel ball bearings. You can see here, and we drop them on all of our products. We drop them on the top lines of all of our metal woods. We drop them all over our wedges to wear finishes off and things like that. And really what that test is meant to do is test the adhesion of all of our coatings. So any paints, PVDs, chromes, anything like that. So that test is really kind of meant to try to wear the coating off. So for all of these tests that you see here, we have minimum requirements that all of our parts have to test, or we won't use that finish, or we will not use that paint. And then we're auditing parts as they come in to make sure that that durability is upheld through the life of our product. So every product that R&D develops has to get qualified through this lab. And really kind of this is to make sure that we design to manufacture as well, to make sure that the ideas that they have, we can actually uphold, maintain through the life of our products, maintain that product consistency over time. These are called falling sand tests. And really what this is a very abrasive media. It's like sandblast material that's meant to remove coatings. So we actually drop it on our coatings to wear them off. And the reason that we do that is because we know that as for a wedge that's going to be hit out of a bunker, for a shaft that's going to go in and out of a bag 1,000 times, we want to make sure again that the coatings stay where they're supposed to stay, and that the clubs don't wear beyond what we think that they should. We smash driver heads, we smash fairway woods, we bend golf clubs on these things to make sure that we understand the forces of what it takes. We actually go so far as to break our golf clubs to understand what it takes to actually break them. We don't just test to make sure they pass our criteria, we actually test the failure. If we just say that, yeah, they pass our criteria and we stop testing, we don't really necessarily know whether we're getting better or whether we're just maintaining status quo. So we actually test everything until it breaks, until it fails, and then we know kind of where we are and what our baseline is. So we can always make improvements.